In this lecture, we're going to talk about the k-means clusters. After this lecture, we're gonna code our own k-means clustering algorithm and apply it for time series data. As in engineering applications, most of the data we're gonna deal with are in fact time series data. So the k-means clusters, what is the k-means clusters? The k-means cluster is unsupervised, is part of unsupervised machine learning algorithm, and it uses the number of clusters, the k number of clusters, which is k means the number of clusters, to classify a set of points into these k number of clusters. How they do it? Well, by calculating a mean point, thus the name called k-means. Calculating a mean point that is calculated from a set of points. So from all the data, we know how many clusters we have. So in this case, we have 3 clusters. So we can assume we have to input the number of clusters. So we can say 3. And based on the points, we will calculate 3 points that represents these 3 clusters. This is going to be our training part of the work. Now, when we have a new point and we want to cluster it, we simply measure. So if we have, let's say, this point, we simply measure this point to every mean point of these clusters, which should be located in the middle of these clusters. So we measure these distances, and based on that, we classify the new point into the clusters that it belongs to. Now, in order to apply this method to a time series data, as you know, time series data is not going to be only represented by one point. It will be represented by a time and a value. And the value is going to change with time. So the same as we did with the clustering points, we need to calculate again the distance. Now, how to calculate? If we have 2 points, it's very clear. The 2 points, the distance between 2 points is simply the Euclidean distance between these 2 points, x, the square root of x squared plus y squared. It's very simple. However, if we have time series data, in this case, we use the mean square error to calculate the difference between these 2 time series. So the mean square error will equals xi minus mi square. We sum all of these values and we divide by the number of points we have. So if we have one curve and another curve, we simply calculate for every point in here and here xi, the value of this, and divide minus the value of this, and we square this value, and then we keep doing it for all points along the time series. At the end, we will divide it by the number of points, and by that we will get the mean square error value that will represent the distance between 2 points. Another way to calculate it, a little bit smarter way to calculate it, because is using the dynamic time wrapping. And the reason we need dynamic time wrapping is because sometimes we have 2 time series data, but they are a little bit shifted. So what we call engineering phase shift. So if we have they look the same, but because they are shifted, if we use the mean square error, we will get a little bit not so correct answer, because you cannot compare this peak with this value. You have to compare this peak with this peak. For that, we use dynamic time wrapping. And dynamic time wrapping is we will have to put 2 time series curves in this way and calculate every point of this time series, the distance between this point and every point along the time series. And we keep doing this point and calculate the difference between this and every point along the curve, and we keep doing it for all points. After that, we will find from these values, from every row in here and here and here and here, find the lowest number, and basically we will start drawing this line connecting between from the first point to the end point. In this case, or in this example, they calculated the points from the difference between this point and every point in here, and then here and here, and so on. So this is why you find these 2 points in parallel, because the lowest point is in here, it was this one, and then in here it was this one, and so on. After that, we connect them. You can see these points. You can connect them. We can sum them, get the average of these points, and so on. So there are many ways we can do it. However, the idea is we need every point has to be calculated with every other point in the time series. You can understand now why, as a computational efficiency, mean square error requires much less computations. So it's n times. However, because we are calculating every point and the other point, the computational cost will become n square. So n times n. So if we have to calculate 100, if this is 100 points, we calculate 100 times. And in this case, we calculate 10,000 times. So of course, the dynamic time wrapping will be more expensive for clustering.